Hello everyone. Today we are going to discuss the properties of determinants. The property 1, the value of the determinant remain unchanged if its rows and columns are interchanged. Okay, we have taken one example. If delta is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and if we expand along the row 1, okay, so if we expand along row 1, then you need to multiply 9 into 5, 45 minus 6 into 8, 48. Then if you expand along first row, second element position, 2 position is 1, 2. Therefore it will be minus 2. Then 4 into 9, 36 minus 7 into 6, 42 plus 3. So it will be 8 into 4, 32 minus 7 into 5, 35. So if you calculate this, the value of the determinant comes to be 0. Now what we are going to do is we are going to change the rows and columns. If we interchange the rows and columns, what will be the next determinant? So next determinant is this delta 1. Let us assume that this delta 1 is obtained by interchanging rows and columns. Okay, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. This 1, 2, 3, 4, 5, 6, 7, 8, 9 are the rows of the previous determinants. Now this is the new determinants. It's denoted by delta 1. Again we will be expanding this one along with any row or any column. For example, we are expanding this one along the first column, and all of you know how to calculate the value of a 3 by 3 determinant. If we calculate this, the value of the determinant is 0. Therefore we can compare the value of delta and delta 1. So both comes to be 0, so the values are not changed. That means you can repeat the property 1, that according to the property 1, the value of the determinant remain unchanged if rows and columns are interchanged. Okay, now let's move to the next property. So property 2. So property 2 says if any of the two rows or columns are interchanged, then the sign of the determinant changes. In a determinant, if we interchange only two rows or two columns, then what will be the changes in the determinant? According to this property, there will be changes in the sign. Okay, let's example delta is equal to 112, 130, 221. Okay, this is one verification. Now if you calculate this one, expanding along with any row or any column, the value of the determinant is equal to minus 6. Okay, now what I'm going to do is, we'll be interchanging any two rows. Say, we'll be interchanging between the first row and the third row. That means 1, 1, 2 will bring to the third row positions, and 2, 2, 1 will bring to the first row positions. So let us see the next determinants. So next determinant delta 1 is obtained with the help of interchanging the first row and the third row. Then initially 1, 1, 2 was the first row. Now we are bringing down to the third row. 1, 1, 2 and 2, 2, 1 was the third row positions. We are bringing to the first row positions. Now if you evaluate this determinant, it comes to be 6. So can we compare this one to previous determinant? Okay, the value of the previous determinant was minus 6. Now we have interchanged. That's the first row we are bringing to the third row position, third row we are bringing to the first row positions. Now the value of the determinant delta 1 is 6. So have you seen that there is a difference in sign? That means the sign of the determinant changes if we interchange any one pair of row or any one pair of column. Okay. Now the question that what happens instead of changing one pair of row or column, we make more changes. Okay, so that we can explain with the help of one example. Let delta is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay, now we have just learned that if we make the changes of one pair of column, then this delta will be multiplied by minus 1. That means the difference of this delta and the determinant obtained by interchanging any two columns or any two row will be differed by only minus sign. Therefore we will be doing one thing. First we will interchange the first row and the first row and the second row. So if we interchange the first row and the second row, so determinant will be multiplied by a minus sign. So we'll be shifting second row to the first row positions, A2, B2 and C2. Then we'll bring down A1, B1 and C1, and we are not changing anything in the third row, A3, B3 and C3. Okay, we are interchanging the first two rows. Okay, now we can, if we repeat this property, the same determinant once more. Like we are again say we are going to interchange the second row and the third row. Again, if we interchange the second row and the third row, that means what I am going to do is the third row position will bring to second row position will be third, then there will be another minus sign. Okay, so if when there will be two minus sign, so therefore this two minus signs, multiplication of the sign will become plus. That means in a determinant, if we make two changes, that means if we interchange two rows or two columns, there will not be any difference in the original determinant and determinant obtained by changes of the two rows, interchanges of two rows or two columns. Now again, if we want to make more changes, if we want to make changes, that means if you interchange third time two rows or two columns, then again the 3 minus sign will be there. So obviously the determinant sign will be changes. So we can just conclude by one statement that in case of a determinant, if one pair of row or columns are interchanged, the value of the determinant gets multiplied by -1. If two pair of rows and columns are interchanged, then the value of the determinant does not change. And in case if we interchange 3 rows or 3 columns, then value of the determinant changes. Therefore, if the number of changes are odd, so the value of the determinant gets multiplied by -1. If the number of changes are even, then there is no changes in the value of the determinant. Okay, now we can move to the next property. Okay, we can move to the next property. What is the property 3? Property 3 says if any two rows or column of a determinant are identical, okay, then value of the determinant is 0. So you can take an example. Say if we take this is A, B, C, and this is A, B, C, and this is D, E, F. Okay, now we are taking the first two rows are same, that is ABC, and the third row is DEF. Now if we evaluate this along the first row, okay, so we'll be getting this expression if we evaluate along the first row. Now let us see the value of this determinant. Okay, now the first term is ABF. Okay, ABF plus, so it is ABF minus. So obviously this one and this one you can cancel. Next term is minus AEC, and this is plus AEC. So this term and this term will get cancelled out. So what will be left out? Left out will be only two terms. What are those? That is minus plus. So BDC, and this is minus BDC. So obviously these two terms will also get cancelled out. So finally the value of the determinant is 0. Okay, so we can repeat this property. If any two rows or column of our determinants are identical means the values are same, okay, then the value of the determinant is 0. That is a verification with the help of a simple example. So let's move ahead. Okay, now if each element of a row or column of a determinant is multiplied by a constant k, then the value of the determinant gets multiplied by the same constant. Okay, one verification. So let's take the example. Say delta is equal to 1 to minus 3, 1, 0, 3 and 2 to minus 1. So simply we'll evaluate this. Then after evaluation we see that value of the determinant is 2. Now what I'm going to do is we are going to multiply any one row or column by a constant. Say the first column we are multiplying by 2. Okay, without making any changes in the second column and the third column. So if we multiply the first column by 2, so we are going to get 2 to 4. So that can be seen with the help of these explanations. Say let delta 1. Since we are multiplying the first column by 2, therefore this will be a new determinant. Okay, let's compare this new determinant delta 1 with the previous determinant. So initially it was 1, 1, 2. Now we multiply this one by 2. So in this case, the constant is 2. That means here the k value is 2. Now let us compare that what will be the value of this determinant delta 1 and the previous determinant delta. Okay. After evaluation thus, we see that the value of the delta 1 is 4. Now let's compare. Okay. Compare the previous one. The previous value of the previous determinant is 2. Now the moment you multiply the first column by 2, this determinant gets multiplied by 2. Therefore, this determinant gets multiplied by k. So you can just go back to this statement. If each element of a row or column of a determinant is multiplied by a constant k, then its value gets multiplied by k. So one more simplifications regarding this. Okay. Let delta is equal to k a k b k c, then k a1 b1 c1, k a2 k b2 k c2. Okay, then a3 b3 c3. Now in this example we have multiplied two rows by the constant. Then what happens to the determinant? Okay, how the value of the determinant gets affected? Okay, according to the property that if a row is multiplied by constant, then determinant gets multiplied by k. Hence, we can take k common from the first row. So we can take k common from the first row. Okay, then since we have taken k common, so a1, b1, c1 will be the element of the first row. Other two rows will remain as it is. Now we can repeat this property for the second row as well. So in the second row also k constant. We can take k from the second row also. So k is going to be there. So now we can rewrite the rows. So it will be a1, b1, c1, a2, b2, c2, then a3, b3, c3. So we can understand this way that if instead of one row, two rows are multiplied by a constant, then the value of the determinants gets multiplied by k square. Similarly, if this is multiplied for all the three rows or the three columns, then the value of the determinants gets multiplied by k cube. Okay, so we'll move to the next slide. Okay. Yes. So here one important remarks. If the corresponding element of any two rows of a determinant are proportional, then its value is 0. So actually this is the outcome of the property 4. Okay. What is that? If the corresponding elements of any two rows or columns of a determinant are proportional, then its value is 0. So you can explain this one with the help of one example. Okay. Let delta is equal to a1, b1, c1, then k a1, k b1, k c1. Okay, then it is a2, b2, c2. Right. Now if we compare the first row and the second row, a1 by ka1 equal to b1 by kb1 equal to c1 by kc1. That means the elements of the first row and the second row are in proportion. Okay, now then what happens? What will be the value of the determinant? Okay, so according to the property 4, we can, since the second row gets multiplied by k, so obviously you can take k out. So if you take k out, what will be left out? So the first row is a1, b1, c1, the second row is a1, b1, c1, and the third row remains as it is. Okay, yes. Now we'll be using the property that in case the two rows are identical. So we have learned a property today. If two rows are identical, the value of the determinants will definitely be 0. So hence, finally you can say that if the two rows or two columns, if the terms are in proportions, the value of the determinant will always be 0. Okay, today we have discussed about the 4 properties, important properties of determinant. We have got more properties to explain, so I will be coming the next video with the remaining properties. Thank you for watching this video.